Alright everyone, so welcome to our class on designing REST APIs. One key point to address here, we are focusing on the design of APIs. We will build a REST API very briefly, but that will not be the focus. The focus will be on the design portion of it. Okay? This assumes that you already have some knowledge of programming. Given the introductions we did earlier, most people have that, so not a problem. If you want to catch up on some of the technologies that we'll be using during the example portion, you can look at our previous videos, or if you have been at our previous events, you will already have that. Let's go ahead and get started. First off, disclaimer, this is a combination of my personal knowledge and research that I have done. This is not perfect, I am not an expert, okay? This is just what I have found useful in my professional life, okay? And I hope that you will find it useful as well. Some of the things in here are actually more advanced than what I've done directly, but I plan on using them, and I hope that you do eventually too. I do cite my reference here, and I will share this presentation with everyone after the event via Discord, okay, and on Facebook and Meetup if that's how you found us. Okay, so if you want to look at this later, you will be able to do so. All right. Today we'll be covering from the absolute basics of the design side of things all the way to an example at the end. We'll be covering what is an API, because a lot of people seem to struggle with that in my past experience. They have a hard understanding of what API even means. We'll go a little bit over HTTP, basically how the internet works. Okay. We'll go over data formats that different APIs can use, because while modern tools are unified on one format, if you work with older systems, they may be different formats, and you need to be able to recognize these. Okay. And then we'll cover RPC APIs, which is how many APIs start out, followed by what is REST, what exactly is the thing that we'll be learning, then the different levels of REST, because normally you don't just start out with a fully complete REST API already, you take it in steps, right? And then lastly, we'll go over documentation. Now that you've built your API, how do you document it? How do you share it with other people? Can you see okay? Is that better? Okay, cool. All right, any questions about the agenda? Great. All right, so what is an API? I struggled for a while to find a good metaphor, but this is the one that seemed to stick with people that I have taught in the past. A REST API is like a drive-through, okay? Or you can think of it just like any ordering, since drive-throughs aren't terribly common in Korea. Where you come up, you drive your car up to the place, right? You say your order, all right? And then they say, okay, please pull forward. And inside the restaurant, they're making the food, they're packaging it up, all these kinds of things, right? And then by the time you drive forward, they give you the food, right? So you request what you want and how you want it. Then inside, some stuff happens. You don't see it, right? It's just happening inside. And then you get what you asked for. And that is an API, okay? Metaphorically. You request something, you wait for things to happen, and then you get your data, okay? So the data is your food. So what does API stand for? It is short for Application Programming Interface, okay? If we translate that to normal English, it's basically, say you're writing a program that wants to get information from some other application, like Neighbor Maps, for example. It provides a way for your program to talk to that application to get information, okay? It's basically just a way for one machine to talk to another machine, okay? So far, so good? Cool. Often, if you're using websites or mobile apps, this is how you get data. So for example, let me pull up a browser real quick. If I go to, oh geez, I should have thought of an example. Here we go. If we go to LinkedIn, hello, LinkedIn, right? And if we look at, so for example, let's filter here. So if I go to LinkedIn and I request some data from LinkedIn, you'll see all of these things in this list down here, right? Each of these is a request from my browser to LinkedIn's API to get data, okay? So for example, each of these posts that you see in this list here, this feed, this is all data that the LinkedIn API gave to me when I asked for it. Okay? Does that make sense so far? Cool. And you can actually, whoop, oh, that's not what I wanted to click. See, this is why I'm bad at video games. I can't click. If you were to click one of these, okay, you can actually see the data. Wow, that's helpful. Let's try a different one. Maybe, why did I do that? Maybe settings. There we go. Yeah, you can see this is the kind of data that the API might return to me. And then the browser uses this data to do stuff. Okay, we'll get into a little more detail about that later. Okay, so that's an API. It's just one computer, which could be a browser, it could be a mobile app, talking to a server to get data. All right. Now, most APIs these days use something called HTTP. If you've typed in a web address, HTTP, it's the same thing. Okay, it's short. So this is actually an example of an HTTP request. Your browser is doing this kind of work in the background, and you don't have to see it. The browser does it for you. So the browser says, hey, I want to get data from google.com at some address, and then Google responds with some data. This is like metadata, right, about how the request worked, when the request happened, these kinds of things, along with the actual web page. This is a web page. It's a very tiny one, but you get the idea. Okay? You don't need to memorize this. This is just an example. So what is HTTP? Hypertext Transfer Protocol. That sounds like a bunch of complicated words, right? But I promise it's not that complicated. Protocol just means it's a way that we've agreed to talk, right? For example, in this group, there's the kind of implicit agreement that I will speak to you in English, right? That's kind of the standard format, right? We could call that a protocol, right? The protocol for this event is that I will give you information in English. That's all it is. We've agreed that something's going to happen in a certain way. Okay? Transfer is just sending data over a network, right? You're going to some server out there from the internet to get the web page, right? And then hypertext, honestly, the term is kind of bullshit. It just means some sort of text data, okay? Usually it's some sort of special format like HTML, CSS, JSON, XML, all these kinds of things. Really, it's just some kind of text. That's it. Now, HTTP has a whole bunch of different components, like the URL, the method, the headers, the body. We'll get into that later. And the big thing is that it's transactional, okay? It's not you make a connection and then you do a whole bunch of stuff. Like, they might send you 2 messages, you might send 5 messages. It's not like that. It's request, response. Request, response, okay? That's HTTP, okay? And as mentioned before, it's just a way for 2 computers to communicate. Questions so far? Am I going too fast? Going too slow? Cool. Huh? Okay. All right, so we mentioned that there's this data being passed back and forth. And if you saw in, crap, where'd it go? Did I close it? This example, you see this right here is a whole bunch of like weird quotes and curly brackets and colons and commas, right? These are different formats that an API can choose to send data in, okay? The most common one is JSON, okay? It's short for JavaScript Object Notation. You don't really need to know that. It's called JSON. It looks like this, okay? Where you have these curly brackets, and the curly brackets say, this is starting some JSON, this is ending some JSON, all right? So basically, in between these, there's data, okay? Following that, JSON has a key value format, okay? So key is just saying, this is the type of data I'm going to give you, and then this is the data, okay? So the key could, instead of key written here, it could be something like ID, or name, or image location, or something like that. And then the value could be ID as 1, or name as beach, or image location as Flutter or something. I don't know. I don't know what the cool kids use these days. JSON can also use different data types. So this is text, right? But it can also use lists. So you can store multiple values in one key. It also supports other data types like Boolean, true, false. and objects. You can put JSON, inside JSON, inside JSON, inside JSON as many times as you want. Okay? Does that make sense to everyone? Because this can be a little difficult the first time you're hearing it. Good?
If they put JSON inside JSON and JSON, then how do they find which one is the key?
So that's a good question. So let's see, what's a good example? So let's say that, let's say I want to get this value right here, this data value, right? In my JSON object, first I would access the key called object, all right? And then that would give me this JSON object. And then within that JSON object, I would access the more key. So you just keep going key by key by key by key. Does that make sense? Yeah. Yeah, so depending on the language, it could be a dot. It could be square brackets with quotes. In languages like Python, JSON translates to a dictionary. In languages like Java, it translates to, I believe, a map. In JavaScript, it's just an object. Okay. So far, so good? Cool. Oh, sorry, the other formats. I should have put examples. I apologize for not doing it previously. XML example. Now, XML and the other formats are not very often used. Where is my mouse? Here we go. This will work. So XML looks like this. It's gross and ugly and terrible, but it's descriptive. So you know how in JSON you have this key and then value? XML is similar, where you have this tag is kind of your key, right? And then what's in between the tags is the value. The tags being the things in the kind of triangle, less than, greater than symbols. Okay? So name would be the key, and perfect diffuser, okay, would be the value. And then for JSON within JSON, this material key right here would be the same as this object key. And then you have another object inside, and that object would be this right here. So if you wanted to access this thickness right here, you go layer, material, thickness. Okay? It would be the same as going object, more, to get the data value. Good? All right, and then, where is my presentation? And then you also have SOAP, which is actually a wrapper for some sort of data. We're not going to cover that because SOAP is a mess. So if someone says, oh, our thing uses SOAP, you should probably run away. It's not fun. You can figure it out, but it's just not a good time. Okay? Questions about data formats? Cool. All right, now onto the actual API part. Okay, what are different kinds of APIs? Oftentimes, places will start out with what are called RPC APIs. RPC is short for remote procedure calls. Usually, let's say you have like, where's my browser? If I had exampleapi.com, right, I could do a remote procedure call example would be / get user list, right? Let's actually put that over here because that's going to be easier to read. So, oh, hello. Oh, cannot type. So this would be an example of a remote procedure call, right? Where this is just the name of some function, okay? I'm just telling the server, hey, execute this function for me and give me the output, right? That's kind of old style, classic way of doing APIs. It's still used today, it's just not as popular. And in some cases, that method of designing an API works just fine, okay? But in modern, more large-scale implementations, it's not really effective for growth, okay? So that's just kind of a little history lesson. Now, what is REST? This is what everyone's here for, right? It's short for Representational State Transfer, okay? This is kind of the important bit. Data on the server is called a resource, okay? For example, in the RPC example, in the RPC example, oh my god, okay. In the RPC example here, we have this get user list, right? User would be an example of a resource, okay? If you come from a Java background, it might be a class, okay? Or Java, Python, actually most languages. This would be equivalent to a class, okay? And then that resource is represented in some state, right? Because things change over time. So the representation of that resource in the current state of time, right? And then the transfer bit is we're communicating the data back and forth between the API and the client, okay? Between the API server and the mobile app or the web browser, all right? As mentioned before, this is a more modern API design, and we actually use HTTP to help make things more clear, which we'll cover later. The big thing about REST is that if you understand the principle of resources, and if you understand HTTP, it's really easy to kind of just guess about how the API works, and you'll probably be right. So for someone who's experienced with REST API design, you could just give them a list of like, oh, oops, not yet. You can just give them a list of something like get/user, get/user ID, put user, post user, delete user. And if someone knows REST API design, they already know exactly what this does. Okay? And that's what we'll be teaching you today. All right? So this is where the intuitive part comes in, and why REST is a good design, because it allows us to just look at the specification and we can start coding immediately. All right. Questions so far? Yeah.
So can you open that notebook?
Sure.
Here, the REST APIs are like adding the user, updating and deleting the user. For RPC API, how would the things be? Like
RPC would be something like
update user list.
Yes. So REST style, and let's say, whoa, okay, page down didn't work. That's cool. Let's say RPC style. All right. So the equivalent of these might be get user list, and then get user by ID, and then edit user, create user, and then delete user. Right.
So isn't it same like the REST API?
It kind of is, yes. Now, the difference being that when you get into nested resources, that's when RPC gets a little messy. So let's say that a user has, thinking of examples on the fly. Let's say a user has photo albums, and then those photo albums have photos inside, and then those photos might have tags, right? You don't want to have some RPC endpoint like get tags for photo of album by user. Like, no, that's not fun, right? And this is where RPC starts to kind of break down, right?
So everything has to be specified in advance, right? Is that what you're saying? If you've got a case where you need something, you have to specify it out, and RPC it'd be impossible to specify every single thing.
Correct, and that actually brings a good point that I probably should have mentioned on this slide, so thank you for bringing that up. One of the big things about REST, when you get to a kind of final level of REST API design, is that you can find resources without any documentation. Okay, you can just go to the API, and if you just hit the main page of the API, the data that it returns to you will allow you to navigate through the API to find what you want. You don't have to find what the name of this special function is. Based on the data that the API gives you, you can just find a route there. That may not make a whole lot of sense. You're probably thinking, how, what, how? That doesn't, what? We're going to get there, okay? So, good point. Thank you, Damien. Does that answer your question, Sam?
Yeah.
Cool. Any other questions? Cool. All right, so now when as I mentioned before, you can try to build a nice, fully defined REST API at the very beginning, but it's a little bit of a challenge if you've never done it before. And a lot of the times you don't have the full amount of information. So usually we talk about progression of REST APIs in levels, right? In terms of levels of maturity. How complete is the design, right? So most of the time, we'll start out with RPC just because we can get it done faster that way, right? As a developer, I could just say get user and then write my code and I'm done, right? I don't have to think about, oh, should it be get or post? Should it be /user? Or should it be /organization/user? Or these kinds of things. So we'll start with RPC, but then we'll go to level 1, right? There's basically some guy made a blog post being like, these are the 3 levels of REST. And a lot of people are like, yeah, that sounds good. I'm going to follow that. So that's what we're doing too, okay? So level 1 of a REST API, your first step to making a fully complete REST API is to organize your data into resources, okay? If you come from an object-oriented programming background, like Java or, oh crap, basically anything that uses classes, this will be kind of easy for you, okay? You might have a user class, or an organization class, or a building class, these kinds of things, right? And those would often be your resources. A lot of the common examples is kind of a library, where you have an API for books, right? So you might say, okay, I'm going to organize all of my data in my API by going, if I want to get some data about books, I just go to /books, all right? And that's where I can find all of my data about the book resource, right? And then that's where kind of this part, here, if we copy this guy here, let's just do, how does this look? Okay, so this is kind of step 1, right? You have some user as a resource, right? And then you send a message to the API and you do stuff to that resource. You can say in the message like, oh, edit user with this data, or get this information from the user, right? And then if you want to get information about a specific user, usually, or a specific book in this case, sorry, I switched resources on you here. Then you would do book / and then some identifier for the book. Often this will be the ID of the resource in your database, right? If you have some database backing things. Some people actually think that's a terrible idea. It's kind of a design choice. Usually I use IDs just because it's easiest, and usually I'm not working with financial data, so sharing IDs doesn't really matter. But this is kind of the common way of doing things. If you want to access data about books, you have my API whoa, hello. You have something like myapi.com/books, and that will get you data about books. Okay? Everyone understand that? And then if I want to get data about a specific book, I would do something like myapi.com/books/1. And that will give me information about the book whose ID is 1. Okay? Now, once you learn this kind of pattern, it's pretty intuitive, right? So you can see, oh, myapi.com/books. Okay, I must be getting information about books, right? That's pretty simple. But it can also get a little more complicated, so I can do something like books /1/author might give me information about the author, right? Or actually, that's not a good example. If we do chapter, right, that'll give me information about the different chapters of the book. If I want to hear about chapter 10, I can just do this. And kind of by following this structure, let's get this higher on the screen. By following the structure, now that you understand that REST APIs are resource-based, you can just look at this address and understand what we're doing, right? So if we do another example, if we do something like restaurant.com/menu/4, and let's say, no, here we go. Let's do branch 10, menu 4. Who wants to raise your hand, who wants to take a guess at what data this will give to me? Someone be brave, come on.
10th branch of that restaurant and from the 10th branch of REST, it will return the 4th menu.
You got it. And just to repeat for the purpose of the video, at the restaurant, at the 10th branch, we'll get the 4th menu item. And just now that you understand REST API design, now that you understand how this is organized, just by looking at this address, you know that already. You don't need any fancy documentation. You don't need anything crazy. You can look at this and you're good to go. Now, the difficult part is you don't necessarily know what this data looks like, right? Is it JSON? Is it XML? Will it tell me how much that menu item costs? Will it tell me what ingredients there are? These kinds of things. That comes later. That's level 3, 2, 3. We'll see. But to start with, this is a good start for level 1 of a REST API. Okay. And the big part is that if you're doing the backend, if you're building the API, and you have a separate front-end engineer, if they understand REST, they don't have to talk to you as often. You can just say, here's all the endpoints, figure it out. And they'll go, I can do that. All right? Ideally, you want to give them a little more documentation than that, but we'll get there. Okay? Everyone good for level 1? Cool. Now, level 2 is when we start using HTTP to help us, right? Previously, we just had the web address, right, to set up the resources and figure out which resource we're getting. But we can use the HTTP methods for clarity. Remember I told you earlier about the URL, the methods, the header, not to worry about that? We're going to worry about that now, okay? So these are kind of the most common HTTP methods. And these are used when a client requests data from the server or makes an HTTP request to the API. The method that they use suggests the kind of operation that they want to do, okay? Get basically just gets data, okay? And the client should expect that if I make a GET request to the API server, I'm not changing any data. I'm only reading data. I'm not changing anything, okay? That's a GET. Post, mutable may or may not be the best way to describe it, but post basically means you're changing some data, and if you were to make that post repeated times, you'd get different data, okay? What that translates to in practical use is post is often used to create new resources, right? So if I go back to my books API, if I do something like an HTTP post books, right, this would create a new book, okay? Does that make sense? Cool. And then put is similar to post. Some people don't bother using put, they just use post for everything. But the purists are like, no, post and put are different. Put basically means that if I do an operation on the server, I'm changing data, and if I do that operation over and over and over again, I'm always going to get the same result. Okay, the data is going to change in the same way. What this translates to in real life is basically an edit. So usually you would do this on a specific book, right? Because you're not going to edit all the books. That's a terrible idea. And this would be edit book 1. So far, so good? Because if I change the author of book 1, right? If I run that one time, it's going to change the author, and that's going to be the author, and that's it, right? If I run that same request again, it's still going to be the new author that I set. So no matter how many times I run it, I'm going to get the same result. Okay? That's why we use put versus post. Some people will debate about the meaning of the two, but most people tend to agree on this one. And what's up?
What is mutable and what is immutable?
So I kind of borrowed vocabulary here without checking if it was 100% accurate. Mutable means that changing, right? So if something is mutable, it means you can change it. Immutable means it cannot be changed. So a lot of times in programming languages, they'll talk about strings as mutable or immutable. It's basically like if I have a string that's mutable, right? If I want to add more text to the string, I can just change that string. right? Immutable means that if I want to add text to that string, I can't do that. I have to throw away the old string and make a new string, right? Basically, the changes that you make have to be unchanging. That is really confusing. Basically, there's a whole lot of theory behind the way they said this, and I didn't entirely understand it. Post is create, put is edit, is basically how I translate it. And then delete deletes a resource. Surprise! All right. Now, a lot of organizations, they'll stop at level 2. They don't need anything more, because if you give this to a client engineer, they'll be able to run with it, right? They'll go, okay, this is list users, this is get information about this user, this is to edit, whoops, that was a mistake. This is to edit that user, and then this is to create a new user, delete the user, right? If you understand REST, you can look at this and you got it. But we can go deeper. This is the kind of fancy area of REST. How are we doing on time? Where not a lot of organizations go this far, but this allows for some really nice automation and makes life much easier for client engineers. Okay? HATEOAS, however you want to say it, is short for, oh shit, did I forget it? Hypertext. Ah, damn. It's so long. Hypertext something transfer engine. Here we go. Hypermedia as the engine of application state. This is, whoever came up with this name is absolutely terrible. But basically, what this translates to is in the JSON data that you create. So let's say that I do a get books 1, right? And let's say that the data this returns, where is my cursor? There we go. Is this returns like ID 1, right? Title, programming is cool, right? Something like this. Whoa, hello. Okay. Let's do this because I don't like that being a new line. Right? That's cool. We have information about our book. But HATEOAS adds this bit. Hello, typing. Now, the format, some people will differ the format here and there. But basically, okay, here we go. Oh, geez. Give me a second. Where's my mouse? There we go. I want to make sure I get this part right. This is the part I'm not as familiar with. So we might have something as, yeah, I got this wrong. We might have something as, if we want to reference the book author, we might have here the author as cool person. I don't know. And then as a link, we can have author and then /author/2, right? And then this would give you a reference to, actually wait, hold up, no, I got this wrong, I apologize. Oh my god, this is looking terrible now. Here we go. And then we might have something like chapters. And we might have something like this. And I got this wrong. Where is my cursor? Holy crap. Books 1 / chapter, right? And in this way, by adding this links and by adding references to all the other objects, we can actually, a client, by getting information about this book, if it wants to get information about the author, it can just look in links, and then it can look at author, and then it can just use this address, right? So the cool part is that this is documentation, right? You don't have to go tell, after you've told your client engineer about the books, right? You don't have to tell them about authors, they can just find it themselves, right? And an even greater part is that, let's say, oh, you don't like the name authors, or maybe, oh, we don't want to use plural names anymore, maybe we just want to use author. You can do that. And if the client is using this to figure out how to find this, it doesn't matter if this is changed. Because the client is looking here to get this value. Okay? So you can change this to whatever the hell you want. And if a client wants to find the author for this book, it's just going to look here, and then take whatever this is and use that. Okay? That's the cool part about this. You look a little confused, Damien. What's up?
I was going to say, is it like a reference to what the foreign key in a database?
Yes.
But then you started doing the second bit, and I'm now like, is it like a reference to a reference of the foreign key to a database? Because you can change the actual text. That's what I started getting.
Well, so your initial thought of this acting like a foreign key reference, conceptually, you're spot on. Okay. The area where your confusion came from is that you have to remember this is an abstraction layer, right? An API is not necessarily a one-to-one match with the database, right? For example, if I wanted to get super fancy, I could have something like, here we go, tags, right? And then I could have something like fiction and sci-fi and new, right? Now, if I had in my database some books table, if we're using relational databases, or a books collection, if I'm using some NoSQL database, well, maybe it wouldn't apply to a NoSQL database, but if we're talking relational, right, I'm not going to have tags inside my books table, right? I'm going to have some sort of relationship to make all that happen. But for purposes of the API giving data to the client, I want to combine that data. So doing a one-to-one mapping with the database doesn't really make sense. It's an abstraction to the idea of a book resource. Does that answer your question?
Yeah. I was kind of confused myself as I was thinking through that. It makes sense.
Okay, cool. And then to kind of follow through with that, you could do something like tags. And then, you know, if the person wants to go look up more information about the tags themselves, they could just do something like this. Right? And let's say we wanted to change it to, what's up?
I have a question. Is this used for links that says where the author is cool person? Like if you want to look up with who's a different author, then you can put links instead of author.
Yes, that's exactly it. So if you follow this link, if you follow the link for author, it will give you the author information about this book's author. That's not clicking. Okay, let's try again. So let's say I had another book. Let's say I did something like this, and I did books 2, right? Holy crap, where's my, there we go. And let's say this is less cool person, right? This is a different author, then this might be this. And then if we followed this link, if we did something like get authors 3, the data would then be something like ID 3 name less cool person. And then what? typing is hard, and then whatever other data, right?
So basically, the links is to give you more information about the title and author. Is that
Correct. So the links are ways to give you information about related data. So in this way, because of these links, a client can navigate through your API to find whatever it is they need, right?
I have a question about the author link.
Yeah.
It looks like you would be linking to the next book. This one is ID 2, but that one is author 3. Shouldn't it be?
And it's a third author in the database, but it's the second book in the database. It's two separate tables, right?
Right. Right. The book is going to have a different ID than the author, because an author can have written many books,
Okay.
right? And each book is going to have a unique ID. The author's ID and the book's ID are not directly related.
Okay.
They can be whatever the hell.
Okay.
Like, you can have your first author in your library might have 100 books, and so you have books 1 through 100.
Yeah.
Yeah. Or if your library has been around for a long time, you might have author 345, and maybe their first book is ID 1242,
Yeah, that makes sense.
something like that. So does that make sense now?
Yeah.
Cool.
Thanks.
Where else was I going to go with this? Oh, so another particularly nice thing about this is list endpoints. So let's say I do get books, right? Based on your knowledge of REST design at this point, what data what kind of operation do you expect this to give back?
information about books?
Yes, a list of books. You got it. So if I have, so let's say I get some JSON back, and I have, and so we got the list of books, and that's some array. And I know that the examples are where the really kind of critical information from this presentation is. I am going to include this in the online stuff that I'm going to post after the class. So if you're like, oh man, I want to see these examples, don't worry, they'll be there, okay? Well, let's say we have books, ID 1, and then we have even more books, so on and so forth. I can have something like, again, links, right? And then we can have, oh, hello. Nope, that is not how Notepad works. I probably should have used something like Atom. Oh god. What's happening? Okay. I can have something like next page. And then I can have something like books, page equals 1. Or let's say page 2. And then something, oh, whoops, except I made a mistake already. And then I can have previous page. Something like that. Okay? So in this way, if I have paging, like let's say I only show 20 books per page, using this, the client can figure out, oh, how do I get the next page of books? And then you might not know what this is, right? Because I haven't talked about this yet. But you know what? It doesn't matter because this part tells you. Okay? Whatever this is will get you to the next page, right? And whatever this is will get you to the previous page. All right? Does that make sense with regards to the links bit?
Does it refer to pagination?
Yeah.
The API?
Yeah. I'm getting a little bit, I've been trying to stay in the theory layer, and we're getting a little bit into the practical layer. I'm going to get into practical stuff in a little bit.
Okay.
Yeah.
Another question I'll say.
Go for it. What?
Is this referring, when you're saying 2 and 0, are you referring to an indexing? Or, because like a unique ID in a database might be like a long string or something like that. So I was just wondering what the ID refers to.
Specifically with something like paging?
You take books, for example, ID equals 1.
That's usually, so That's a design choice that a lot of people struggle with. There's no wrong way to do that. Usually as long as your ID is something that uniquely identifies one book, you can use whatever the hell you want. Some people use the ID in the database for simplicity. Like that's often what I do. Some people think that exposing the IDs of your data in the database is a security risk. And they'll use maybe some sort of unique name, or maybe they'll create a UUID. But in my thinking, if you have something that uniquely identifies the record anyway, what's the difference between using that and using the ID? So, often it corresponds to a database ID. Questions about this links bit? What you got?
Actually, I'm not even quite sure how I can phrase my question. I'm very confused, but it's about the previous thing. Can you go up a little bit? Yeah, so my question is about the author, which is last full text, and then we have the information about the author 3 down there. And I'm wondering if can you go up a little bit? The author key there? Like the first author key, the last full person, is the program actually retrieving the information from the author 3 down there, or are they completely two different?
No, it would.
So if you put in the author 3 that snippet, if you put like extremely cool person, then will you get extremely cool person as the value of the author key?
That's how it should behave. Yes.
Okay.
Yeah.
They are the same thing.
They should be.
Okay.
Yeah. Oh man, I was really hoping to avoid getting too deep into databases, but we're going into databases now. Okay. Okay, quick thing. Who knows what a relational database is? Raise your hand. Okay, we got 3, 4, 5. Cool. Who knows what a NoSQL, NoSQL database is? Okay, same, 4. Cool. Crap. All right.
It's a relation.
Yeah, but the non-relational is easier to explain. Okay, so in a damn it, how much time we got? Oh, we're good. Okay. So in a NoSQL database, a NoSQL database, a non-relational database, these are things like your MongoDB, your CouchDB, your DynamoDB, thank you, your Firestore on Google, these kinds of things. Your data is actually exactly like this. In those kinds of databases, often, not always, but often, they use JSON, a JSON document, this format to store your data, right? And so if you're using a NoSQL database, a NoSQL database, your data could look exactly like this, okay? And then you basically just take that out of the database and send it to the client, and you're good. You're done. Job's done. You can add the HATEOAS, whatever the hell you want to pronounce it, and you're done. Your job's finished. You're very easy. However, you run into, and this is probably where your question is stemming from, you run into consistency issues, right? Because here, let's say this is my book document in the NoSQL database, right? My book document, but I'm storing data about the author. But then I might have author data separate in my database, right? Now here's the thing where things get confusing. I have data about an author here, and I have data about an author here, but they're supposed to match. They're supposed to be the same, right? And that's where problems sometimes happen with NoSQL databases. Because you have this relationship, this is supposed to be a non-relational database, but you have this relationship. And so in non-relational databases, you often have copies of the data. And making sure that the copies are consistent can be a problem sometimes. Some NoSQL databases actually do provide relationships where you can avoid this problem, but that's something that you may have to look out for. So when you're actually building the API itself, again, we're not supposed to be covering building here, only design. You might run into those inconsistency issues that you kind of touched on a little bit, whether intentionally or not. But in a relational database, what would happen is you would have a books table, and then you'd have an authors table. And these would be completely separate, except in your books table, well, I should probably have this in the camera. You have your books table and your authors table. In your books table, you're going to store this author ID. So when you look up the book, you can grab the ID of that author, go to the authors table with that ID, and get the correct author. And then you're always guaranteed to get the correct data. Because rather than trying to get a copy of the author data, you're going directly to the source. Whereas in a NoSQL database, if you're not using references, you're working with a copy of the data, and if the data has changed somehow and your application didn't update that change, you're going to get some weird behavior and it's not going to be fun. Okay? So does that kind of answer your question? Or I guess your questions together, I guess? Cool. If you didn't 100% understand that, don't worry. That was out of scope for this lesson. We will be covering databases at a later time, okay? At another event. All right. All right. Any questions about what we've covered so far? Going once. Going twice. Cool. Okay. Now the reference I was using to put together this presentation actually missed a critical feature, which I'm a little disappointed with now that I realize it. So you're probably wondering what this bit is, right? Hey, Alex. So previously we covered, we talked about, where is my example? Here we go. When we used LinkedIn as an example here, and I apologize if this is a little bit too small for people to read. Here's an example of an HTTP request, right? So we have the request URL. All right, so this is LinkedIn/Voyager/API/dashboard/my-settings. All right, that's kind of RESTful, I guess. Not really. Whatever. And then we have this get method, like we mentioned before, right? And then, so you're familiar with that part, the URL and then the get, right? However, we got this question mark here, followed by this bit.
You can make a bigger control font.
In here too?
Yeah.
Oh, baby, I didn't know I could do it in this window too. Thank you. All right, so can everyone see that all right? Now, if you're not super familiar with HTTP, this is called a query string parameter. Okay? That sounds all fancy, but query is just a fancy word for question. Hence the question mark. Okay? And then string is just text, and parameter is some kind of input. Right? So we're saying that, now I don't exactly know what this means for LinkedIn because I have not learned about the LinkedIn API, but they're saying that for this my settings request, we're going to also use decoration ID of whatever. So in our kind of simpler example, if we did something like get books, this would list books, right? But let's say I want to do more than just list all of the books, right? Maybe I want to find books by a specific author. I could do something like author ID equals 1. And then that might show only books by that author, right? Or I could do something like tags equals fiction. And that might show books that that only have the fiction tag, things like that. Or I could even say fiction, history, something like that, right? And in this way, you can kind of modify your requests. most often, you'll only see this on GET requests. Because often with GET requests, you're not submitting any data. So if we look at, oh crap, did I lose that one? Crap. Oh, gross. This might be okay. Oh, no, that's not okay. Hold up. Oh, that's a post. That's a GET. Nope, that's, actually, yeah, here we go. So oftentimes, in a GET request, I didn't cover that either, crap. We have in HTTP, we have our URL, we have our method, right? And then we also have these things called headers, okay? These headers define some information about our request. So for example, we want the language returned to us to be English, right? Or we want the language returned to us to be Korean or Spanish or whatever, right? We could say that, oh, did they not use content type? Oh, that's weird. We can say that, oh, we're using the browser, Mozilla, what? We're using the Chrome browser, for example, right? That's information we can feed to the server when we make a request. Crap, where was I going with this? I was going somewhere with this, I swear.
What's included in a GET request and post?
That's right. Thank you. So there's these. This is kind of the header of it. Oh, cool. And then remember earlier I mentioned these query string parameters, right? This is all the question mark stuff, right? So if we wanted to add multiple, we could say and author ID equals 1. Right? This is how you separate query string parameters. Where was I going with this? And usually for GET requests, all of your information is only in the header and the query string, right? Those two parts of the HTTP request. Usually, because you're only doing data retrieval, right? You only need to feed information to the server about what kind of data you want to get back, okay? However, for your edit requests, let me see something that's not a GET. Right, I'm only viewing a profile, so I'm not going to get a GET. Let's do something like, I don't know, I guess we're going to edit my profile. Is there something else I can edit that's not as important? Let me try GitHub.
A comment.
A comment? Yeah, but...
If you try maps, like Google Maps or something, you might have to set like a select for them.
I got one for you. We'll just use one of my example projects. And I'm just going to create an issue. Because this is something I don't really care about. Okay. There we go. Cool. So now, if I'm on GitHub and I create a new issue, right, this is going to do something like my new example issue. Let's clear out all this junk that we're not using. Blah, blah, blah. And, yeah, submit new issue. There we go. Yeah. Oh, look at that. There we go. So, what? Oh, shit. Come on, really? Dude? Are you serious? Okay, let's do this. There we go. Yeah, that's what I'm looking for. Yes, we got a post. Okay. So in this case, I'm creating a new comment, right? So my issue comments resource, I'm doing a post, so I'm creating a new issue comment, right? Holy crap, there's a lot of junk. So now, because I'm doing a post, oh, come on. Where is the thing? Oh. What? Okay, fine. Because I'm doing a post, oh, that's really gross. Why do they do it this way? Okay. In the body of my HTTP request, I have all the data that I want to use to change. Okay? So in the HTTP request, we have the basics like the URL, the post method, the request method. We have the headers, which we mentioned before. We have our query string parameters, but I think in this case we don't have any. And then we have our request body. Okay? And this is where we would want to put data for creating a new, for our post, put, and maybe delete, but usually no, in your post and put methods. Okay? So if I were to do something like post books, creating a new book, in the request body, I might have something like name, or not name, title, tags, right? And this is where I would store my the data that I want to send to the server to change a resource. Okay, so you can think of your request body as what you use to send changing data, and you can think of your query string parameters as your kind of filtering data. Okay, does that make sense? Cool. Sorry, that part I had not prepared because I just realized, oh crap, this is missing and people need to know it, so I apologize if the part was a little bit rocky. Okay? Any questions about this so far? Cool. Alright, and the last bit is probably, before we get into doing an actual example, this part is where a lot of value comes in. Documenting APIs is often not fun, right? So even if we use the full level 3 REST API with the HATEOAS or whatever, you may still have people asking for documentation. Like, oh, what exactly does an author return? What book data is there? What query string parameters can I use to filter things? And in those cases, you'll still need some kind of documentation, okay? And that's where OpenAPI and Swagger come in. These are kind of standards that a whole bunch of engineers all over the world have said, this is how we're going to document APIs, and if we document things in this way, we can build tools to easily show that documentation. If that doesn't make any sense, let's check this out. So this is an example of some API documentation, okay? And then there's a tool called Swagger UI, okay? And Swagger UI reads this data and creates just a little console for you to experiment with the API. So I can just say, okay, cool, let's do, so let's say I want to see store inventory. Rather than like have to create a client, right, or learn curl or anything like that, I can just have my API documentation here, go to my Swagger UI, and I can just test it out. And boom, it'll call the API and I'll get an example response. That is terrible. Who did that? Gross. Soda info will, but you get the idea, right? So in this way, this gives kind of an interface for people to test out our API without having to build a full website or a full mobile app to actually interact with the API. And this is only possible because there's a standard format for documenting the API. So this tool, if you document your API by this format, this tool will work with your API. No changes required. Okay? Now, you're probably thinking, oh crap, this is pretty long. I don't want to have to write all of this. Well, that's not as much of a problem as it sounds, because you have to write code to make your API work, right? You're going to have to write some Java or Ruby or Python or whatever, right? Some JavaScript to build your API. And a lot of these different frameworks and libraries that we use have a Swagger or OpenAPI package that you could just import, show it where your API code is, and in Java you would use an annotation. In Node.js, you would incorporate it into your router, but there's all different ways that you can basically just have a library, look at your code for you, and generate this. Okay? And then you don't have to write any of this. Oh, well, you have to write some things. Like, you're going to have to write the description. Right? Your code's not going to be able to figure out the description on its own. And you're going to have to define some of the relationships. But a lot of the things can be generated for you, and you don't have to worry about anything. And in this way, you can automatically generate documentation for your UI. And when I started doing this, everyone was so happy at my company because I write shit documentation. So when they got this UI that they could just see exactly what they're getting, and they could just play with it and experiment and make sure that things work the way it's supposed to work, they're like, Bede, you're awesome because I don't have to read your crappy writing anymore. All right, so using something like this can make life way easier for you and way easier for the client engineers you're working with. Easier for them because they have something that they could just test and play with immediately, and easier for you because they're not going to bother you anymore. Unless you have bugs, which you always will, and then you work it out with them. Any questions about this? We're going to dive into the details of this in a minute, but about what we've covered so far, any questions?
What does curl do in a nutshell? In one sentence?
What does what do in a nutshell?
Curl. Not
Curl.
curl.
Okay. Curl is a, I'm going to call it a command, that you can use to make an HTTP request. Yeah. It does not ship with Windows. Oh, that's funny. It does not come on Windows by default. I think it's often installed in Linux by default, and I don't recall if it's on OS X by default. Does anyone have a Mac where they know they have not installed curl and you can run a terminal and try typing curl? It comes with Mac. Damn, that's beautiful. Okay. On Windows, you can get curl using something like Chocolatey. It's basically a package manager similar to Brew on OS X. And I think I actually have curl set up. Yeah, like I got curl set up on this guy. So the nice part about Swagger is, let's say you don't want to use this UI. The Swagger UI gives you this curl command that you can test it. So if I copy this here, and I paste it here, it's making the same HTTP request, and it wrote this command for me. I didn't have to write this command. Boom, done. Now, why does it look good here? They must have some kind of bug on this website. That's weird. But yeah. So does that answer your question? Cool. And this is actually, before things like Swagger existed, this was how we had to test our APIs. We had to use a curl command, or we had to write a client. And that was just not fun. But now that we have something like Swagger, it does it for us. Especially because when you visit some web page in your browser, it's doing a GET HTTP request. Right? If you want your browser to do a post or a put or a delete or something different, you have to get some sort of add-on. Browsers don't do that by default when you enter it into the address bar. Right? You have to either pull out the developer console or set up some sort of plugin to your browser, and it's just not a fun time. So instead, people would use something like curl to do it. And while this works pretty well, and I do recommend getting familiar with curl because you're not always going to have a Swagger UI to work with. But if you are in control of the API and you can set up a Swagger UI, you should totally do it because it'll make your life easier. So, any other questions about what we've got so far? Cool. All right. Postman. Postman is basically It's like a UI for curl. Yeah, good question. We actually use Postman a lot. We actually used Postman a lot before we got Swagger UI.
Does Swagger do documentation? Like, does Postman do the documentation?
It depends on the company. In the case of my company, yeah, I don't write any more documentation. I just use Swagger.
No, I mean, does Postman do the documentation part?
No. Postman is just an HTTP client, like curl. Yeah. One more really nice thing about this OpenAPI Swagger definition thing. There are tools. Actually, did I link it here? Oh, where's my thing? Oh, here we go. I did not link it here. Okay. Swagger has a bunch of tools to generate a library for your API. If you have the documentation written. Oh, mistakes were made. Okay. So what I can do is I can actually click here and generate client. I can pick the language, and it will generate a library that I can import into my client and call this API without having to do anything else special. It'll just do it for me. So if I did, I don't know, real quick, raise a hands for JavaScript people. Okay, that's enough that I'm not even going to bother with others. So if I do this guy, and then I open up this JavaScript client. Oh, here it is. Sorry, it's on this monitor. Here we go. Oh God. Okay. Actually, you know what? Can I open up VS Code here? Whoop.
You have to extract it first.
I thought I did already. I did not. Thank you. Let's what, dude? Just give me the damn. Oh, my downloads folder. I have no idea what's in here. Hold up.
Tracy.
Oh, just more development things and my voting ballot. Extract all. Dude. What?
It's on the other screen.
Oh, thank you. I was like, where'd it go? Okay. Yeah, there we go. That's good stuff. Now, can I open up VS Code here? Of course I can't. Why does brackets have it up? Oh, there it is. So now, here is my my API client that I can. Oh, this code is kind of ugly. Actually, no, it's good. It's good. Never mind. This is just documentation for my API based on the Swagger stuff. And if I were to add a new file here, test.js, right? And I were to do something like, actually, I have no idea how. I normally don't use Visual Studio Code, so I have no idea how well this is going to work, but we're going to try it. Can we also split right? Yeah, that's the good stuff. All right. API client is where's my exports? Yeah, there we go. Equals require index. Now, with this, oh, oops, whatever. What? Oh, shit. Oh, is this going to be a, crap. Oh, my JavaScript, my lack of JavaScript knowledge is going to show here. Yeah. Hold up. Oh, man, really? Okay, that sucks. Well, shit. That super sucks. Crap. Sorry, I'm going to do Python because That's just easier for me. But basically, what I'm trying to show you is this will generate a library that will have all of your API functions in code. You don't have to worry about writing the HTTP request yourself. You don't have to worry about setting the headers properly. You don't have to worry about setting up all the query string parameters. It's just going to generate classes and methods for you that it will just work. And then you can just say, hey, client engineer, here's the library. Go do stuff. Okay? I really want to give you guys an example, but I'm not sure if I'm going to be able to in a short time like this. Extract all. Going over here again. Okay. Oh, God. Where'd you go? All right, here we go. There we go. Try again. And let's do something like... Yeah, there we go. Swagger client. Aw, man, screw you. I hate VS Code. Of course. But I could do something like... that's why. I'm going to assume that this is a class. Yes, it is. Cool. And then, but if you're using a proper IDE that's not Visual Studio Code, you would get all sorts of code completion. It would give you your types and all that sort of stuff, and it would just work. So it makes life way easier for your client engineers. Sorry?
You probably need a VS Code plugin, don't you?
Oh, you know what? You're right. Yeah, I'm probably missing the plugin. Crap. You know, if I used this more, I probably wouldn't complain about it as much. But I've only spent maybe 2 hours in Visual Studio Code, so yeah. Disregard me ripping on Visual Studio Code. I'm sure it's perfectly fine. I just don't know how to use it. So yeah, but basically you would have a whole bunch of autocomplete. It would define all your methods for you, handle all your HTTP request response construction, and you're good to go. You don't have to worry about any of that. No, go away. So yeah, so that, however, that's all dependent on you writing this, right? Or ideally not writing it if you can get to that. Real quick, I did use this as a source for the REST API stuff. This is in the presentation that you'll be seeing, or that I'll put online, and you can read through this if you want. And it details all the stuff that we covered. It's all XML based instead of JSON based, which is not as helpful, but you get the idea. And for now, we're going to get a little bit risky here. And because I did not have a chance to test this out beforehand, but we're going to try it. From previous sessions that we've had here at CodeSeoul, we built a little server using Node.js and Koa. Okay, Koa is another HTTP framework similar to Express. Basically, the creators of Express went and created Koa because they thought that this would be a better way to do web frameworks than how Express was created. So it's all middleware driven instead of route driven. However, you can still use routes in Koa. If you want to learn more about how it works, you can look at the video that we made previously, or it's well designed enough that you might be able to just guess at how a bunch of it works based on what you see here. But what we can do is, oh geez, you know what, let me pull up the example while I'm doing this so I don't absolutely wreck everything. Oh, I have too much crap open. Nope, that's not what I'm looking for. Oh, I hope I didn't close it. Oh, did I? Yep, I closed it. Crap. Okay, you guys are going to get to see me struggle through some code. It's going to be great. Oh, except I found it. Oh, baby. Okay, we're good. So, we're doing it live, people. Koa has... That's not what I'm looking for. This is what I'm looking for. Great. So if now previously I did install this library, Koa Joy Router Docs. This is a Swagger implementation for Koa. Okay. If you're using Koa, you would probably want to use this. However, there are Swagger docs for all sorts of other libraries. There's one for Node.js for Express if you're doing Express on Node.js. There's different ones for Java if you're doing Java. I'm sure there's ones for PHP, Ruby, these kinds of things, though I haven't used them. I'm very confident that they exist. So if you search for my language, Swagger API or Swagger documentation, you will find something. Okay? And then you can use that to automatically generate most of the Swagger documentation. So if we, in Koa, as an example here, all these comments are from a previous class, so if we do something like, oh geez, Swagger API from Koa Joy Router docs. Oh man, I hope this works. We can do something like, for a given endpoint. So in this case, I have. I'm just getting the root now. Let's just create a new router. So if let's say we're doing that books API again, right? I can do something like, okay, let's create on my API server a route to accept GET requests at the path of books. Whoops. And we're going to output JSON. And for 200 responses, that is OK responses, we are going to have the response body be some Joy object. Joy is just kind of a validation framework. You don't need to worry about it too much right now if you don't know what it is already. And we're going to have this be some sort of number that is an integer. Whoops, we're missing a method call here. And then we're going to have some title that is a string. Cool. Okay, so I'm getting auto-completion here, so I must have been doing something wrong earlier. All right, so this is just kind of an example of a super basic books endpoint, right? And this probably looks familiar based on what we covered earlier. But with the Swagger stuff, now I can do something like, I'm missing a comma here. Okay. I can add additional information. We don't need this because JSON, or because JavaScript. And I can say, get a list of books. God, I hope this works. Hello, caps lock. I don't know why I keep putting these quotes. Whoa, hello. Oh, too big, too big, too big. See, I know that this that watching someone type is not very exciting, so I try to be entertaining. So I don't know why I'm using double quotes either. Just habit, I guess. And then okay, so we got that, and then we got that. Oh crap, handler. Crap. I'm just gonna add some bogus thing here. Handler is some function, some async function that takes into context, and on that context we set the body to some object where books is an array of an object. Never do things like this, people. Cool. There we go. That's a crappy little handler. And then that's good. Oh, and let's say that we have some sort of... No, that's good enough for now. Then I'm just going to take this stuff here. Cool. Yeah. And we're going to copy and paste this. Ooh, hello. Oh, and we're missing a semicolon here. All right, now this that I just copied and pasted, this is this is the import that we did before, right? Our import Swagger API, okay? And this is our generator. It generates our documentation. We take the router that we set up our routes on. We give it to our documentation generator, and we tell it to generate a spec. The spec is basically the spec is this thing. This is your OpenAPI or Swagger spec. Okay, it's short for specification, and we add some information that's going to be shared for the entire API. Something like it's like the title of the API, a description of the API, the current version, how to get to it, these kinds of things. And then we define a new route that will give us this spec, okay? And then this right here is just, this is the Swagger UI, okay? Because the spec, remember, the spec is just this, right? But this is the UI, this is the Swagger UI, this is the cool part that we want to see. So this generates the spec, we expose the spec at this API endpoint, and then we can use this to access the UI. And I'm going to really hope this works. Crap, I don't even remember what the hell I called this. What is it, just run? I think it's run. No, it's start. Of course it is. Oh! Hey? Oh, you don't like that, huh? Oh, rip.
You need to import it.
I did import it. At least I thought I did. Crap. Hold up, let me check my example. Oh, sorry, folks. What the hell?
Do you need the new keyword?
Sorry?
Do we need the new keyword?
Did that already.
Oh, I mean, that's what it's pointing at. I just wanted to make it
Yeah, it should be. Crap. So this exports, yeah, what the hell? Swagger API. Oh, maybe,
That's quite good.
this is what I need to do. That was the problem. There we go. That's what we're looking for. Because it's a named export, not just a default export. Oh! Oh. What? Okay, it doesn't like new. Swagger API is not defined? Dude, I have autocomplete. Sorry? Thank you. Damn. Good catch. Oh. Dude, what? Huh?
It's underlying the named export.
Dude, but no, I'm using ESN. I'm using ESN. Alright, fine. Can I do it in the common way? Will it let me do that? Let's try.
There is an example given the last
Here?
Yeah. They're expecting import like that.
Right. And that's what I did. Well, the problem is that if we look at... Here, let's do... Oops. If I look here, oh. Why is it going here? Ah, here we go. It's a named export, not a default export. So this would be for a default export, but in this case it's a named export, so we import it this way. But I don't think this is going to work because I'm using ESM, not common. Yeah. Ooh, oh my god, this sucks. What? I commented that out. Yo, something's weird. Oh. No. What the hell? Dude. I saved? This is commented out.
Maybe it shows up somewhere else in the web.
Oh, maybe.
You can delete that line.
No. I think he's right about it showing up somewhere else. Oh. What?
So I think it's better deleting that.
Yeah. That's weird though, because that's not how Node.js works. Did I import it in here for some reason? No. Weird. Requires not defined. Yeah, because I'm using ESM. I'm not using. Shit. I'm sorry, guys. Whoop. This should work because I'm doing it like that here. So I did save.
Anything stop? Can you hear anything starting?
I thought I did, but let's go ahead and check it again. Because it's saying that it's expecting this, the requested module is expected to be of type common, which does not support named exports. Wait, it does not expect named exports, but it's doing named exports. What if we do... Oh, no, I already did that. No! Yes! Windows Y. Okay, there we go. Swagger API is not a constructor. Cool. Oh my god, this scrolling is terrible. Okay, here we go. Okay, whatever. Do I reference this anywhere else? Nope, that's it. Cool. Try again. What? Generator. It's not a constructor. What? Okay, fine. No, up here. There we go. Try it. Yep. Boys and girls, this is why you test things beforehand. Dude, I just removed it!
Is it the name? Because you've changed the import name, you have to change it back, or is that fixed?
I already fixed it. You're talking about this, right?
No, not on the import, because you can import everything as Swagger.
Yeah.
But then you've referenced it through the documentation, yeah.
Right.
Is it something to do with the build?
It shouldn't, because it should all be... Whoa. It should all be... it's an interpreted language, right? So it should just... is not a function. Then what the hell is it? It's a class. But now you're telling me I can't construct it. Oh. Maybe those are static methods. Oh, shit, I didn't save. Oops. Try again. Cannot read property add joy router of undefined. Dude, I'm getting auto-completion on this. Crap. I wish I had my work code. Oh, I do. Sorry, folks. Oh, but it's not going to be in the recording. It's definitely edited in. In CommonJS, we're using new, so it should just work. Ooh. I apologize that you guys have to sit through and... Well, let's just, I don't know, should we just abandon this part? Yeah, let's just abandon this. This is taking too long. I apologize, folks. But basically, in a properly prepared presentation, we would have, this would be generated by the library. You know what, let me just show you the library. That would be better. Here we go. So usually, oh, no, that is the wrong thing. Yeah, we're using ESM, so I couldn't really replicate this. But you would import your Swagger library, and then as I did before, you would just add your Swagger metadata, and then later you would let's make this bigger so everyone can read it. You would generate your Swagger API object, and then give your router to Swagger. Now, whether you're using Java or Node.js or PHP or whatever, this is usually how you'll do it. You'll have your documentation object, you take your routing system, and you just put it in there. It'll parse through your routing system, and then generate the spec for you. So if, you know what, I can probably just clone this down, huh? Let's try that, because does this have a... Yes, it does. All right, we're just gonna clone this project. Actually, you know what? We probably don't even need to because we already have it. Hey, hey, there we go. Oh God, deprecated. Are you serious, dude? Come on. Maybe it'll still work. Did it at least do node modules? Crap, it didn't. Nope. Okay, so what we're going to do instead is we're going to do something like this. And we're going to copy item, recurse, force. Actually, let's go up one. Copy item, recurse, force, example to this path / Swagger example. Cool. And we're going to close this. We're going to add this folder to our workspace. Oh, geez. Okay. Okay, here we go. And we're going to cool. Good. Okay, npm install. Whoop, actually, no. Where's npm install save koa joy router docs. Cool. And then in our routes here, oh, where's our package? Do we have a script for this? npm run start. Oh, damn it. Cannot find module koa. Oh, npm install. Huh. Cool. What? Dude! Yeah, it's the same error. How about we just do this? Maybe that'll fix it. Unless it's some sort of dependency error, which would be gross, but... There we go. What? Oh. No, dude, get out of here. We don't need this. We're already in example. Cool. Right. Okay. Oh, wrong file. We want this. Nope, we want this. And this should be koa joy router docs. There we go. Okay, so now I apologize for the delay, everyone. If we go to our local host and we go here, oh, they got the new version. Oh, that's fancy. This is actually the new version of the Swagger UI, but it's the same idea. So we can actually, if we click this download button, oh, nope, that's actually not what I wanted to do. If we go to this address, remember how earlier I mentioned, let's get this a little bit smaller. I was talking about how this right here is the spec, right? It generates the spec for us. Okay, so for these routes, this user ID, this is the JSON that the library generates for us. We don't have to write any of this. Okay, we already wrote code to define these, so it just interprets that code and generates the documentation for us. And additionally, we have this client front end. The way this actually works is if we were to refresh this page, you'll see that it actually just goes and reads the spec from here. Okay? And then uses that spec to generate this whole page, all of this data that we see here. So we can expand this users here. And I'm actually not terribly familiar with the new UI. Can we not run an example? Well, that's kind of terrible. That's, man, I don't like the new UI. Well, this gives us documentation, but it doesn't allow us to test running it. However, I think if we do something like, or wait, do I have it down here? I think I have it down here. Yeah, here we go. This is cool. So check this out. If I instead take my spec and put it up in here, oh, get wrecked. Oh yeah, mixed content. Crap. Okay, well, never mind. Maybe. What? Nope. Nope, it redirects to crap. Okay, but basically, this is still documentation that's useful for your client engineers. where you can see the request body inputs. You can see what type of data. You can see if they have to match some kind of pattern. You can see an example request, and then you can see the output, whether it's 200 output or error output. It provides all of that for you. And then you can navigate up here to look around at the API. And again, this is all generated based on the third-party utility that we just downloaded and installed.
So then, like they would look at the response codes and maybe, like, for example, any guy might design like a component for error messages or something like that based on that UI documentation.
You got it. Spot on. So, yeah, it's actually really disappointing that I can't enter in an example here. That really bothers me. I like the old UI. I'm an old man, I guess.
Here's the option.
Sorry?
Here's the option.
Oh, really? Do you know how to enable it? Damn. Into the spec. Well then. Let's see if
What version you're in?
version of what? Swagger?
Swagger or OpenAPI?
It should be Swagger. Do we see the Swagger version here? We don't. But you know.
At the top of your spec.
Sorry?
The version number at the top of your spec.
Right. Right. Swagger 2. Yeah, so that's Swagger. That's not OpenAPI. So it should. Looking at my work code to see if how we did it. Nope, it looks pretty damn normal. Yeah, the spec definition looks the same. No special values for enabling or disabling stuff. But if you, let's see. Alternatively, Swagger UI code. Download Swagger UI. If you prefer the old version, there is a way to get it. Is this the old or the new one? This is the not showing me screenshots. That sucks. Dude, so where the hell? I want this one. Oh, where did this come from? What? Oh, what? Oh, I see. Okay, you know what? We are going to... Oh, no, that's not good. I don't want to copy all that. Yeah, but basically, the important part is that you can get this example UI, and there are tools you can use to generate the response. So Swagger generate client. So API code, Swagger code gen, that's what it's called. So on Swagger UI, you can download this code gen utility. And all this crap going on here. And then they should have some sort of install here. Versioning. I just want to see how to install it, my dudes. I just want to see how to install it. Installation. Why is it not a link? Compatibility. Dude. What's that?
Oh, I had a homebrew installation.
Yeah, but I'm running Windows on here. So rip me. I guess I can't. Man, my environment is not good for this shit. Yeah, there's a whole bunch of Docker stuff. Yeah, it's all looks like only homebrew. Oh, I'd have to do it on Java. It's all Java made. Crap. I'm not going to do that right now. But if you have the time to go through and do this, because I've already wasted enough of your guys' time, you can download the Swagger Code Gen tool, and just like we were showing before, based on the spec you can generate a client in whatever language you want, and it'll just work. And then you can just send that to your client engineer, whether they're doing mobile or web, and then they can use your API. No special things needed. Cool. I apologize, it was really confusing and kind of a mess at the end there. But does anyone have any questions about what we covered today?
Just when you're actually building the API, where do you define all the how do you define the build of the API?
Like the design and structure of it?
Yeah.
So that's going to depend on the framework you're using. Ruby on Rails is going to be different from Koa, is going to be different from Spring Boot. They all have different ways of doing it.
Sort of like, it's kind of like you're running a function or something, and that function will be, if it's a SQL database, it will be where and blah, 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 blah.
Right. So using Koa as an example, when you're defining your routes for your different API endpoints, like that's when you define your Swagger stuff, you define all this, it does that for you. Alternatively, for Spring Boot, because Spring Boot is really common. No, it's Java. You can see, oh, this is terrible. Whoa. You define a docket bean, it looks like, and then you should have, nope. What? Is that it? Oh, damn, you don't even have to do, yeah. In Java Spring, you do your request mapping, you define what the endpoint is, and then the HTTP method, and then you have your function. Again, it's the same thing as Koa, just it's a different format. They use decorators with various parameters, whereas Koa just uses an object, right? Different frameworks are going to do it in different ways.
Yeah.
Yeah. Any other questions? Oh, nice! Okay. Yeah, but it would have been better if I'd, had that last part prepared and not just flailed all over the place. I apologize if that was boring for folks, but yeah. So, no other questions? We're good? Cool. All right. Well, thank you for coming, everyone. I appreciate it. Again, I apologize that things were a little confusing and messy at the end. But like I said, I will put these notes online. I should probably save them if I'm going to do that so I don't lose them. REST API class. If you have more questions, or if you run into problems, or something's not clear to you, you can always join us on Discord and send a message. I do have it set up on my phone, so there's a high likelihood I'll see it pretty quick. Not always, but usually. I will post the presentation, these notes, and I'm going to spend some time either tonight or tomorrow getting my example code properly working for you guys. And then I'll post that up too on both Discord, Facebook, and Meetup. So however you heard about us, you'll be able to see it. For folks who came from Free Code Camp Seoul, if you look on Facebook for CodeSeoul, we'll show up, and that's how you can find this stuff too. Unless you join the Discord, you can just go there. So yeah. Thank you for coming, everyone. We usually grab food afterwards, so if you don't have anywhere to go, you're welcome to join us for dinner. And otherwise, thank you for coming and have a great night.